Hello everyone, this is Mrs. Lopez. Today we are in lesson 4 in module 2 of grade 7, efficiently adding integers and other rational numbers. So now we are definitely moving away from number lines and developing equations. This lesson is a little bit long, so bear with me, and if you need more time watching it, please do so over several days if you need to. So example 1, a rule for adding integers with the same signs. So represent the sum of 3 plus 5 using arrows of the number line. We already know that 3 plus 5 is 8. How do you represent it on the number line? By now you're pros at it. We start at 0, we go with our vector until 3 on the right, and we are adding 5 to the 3. So we start at 3, and we are adding 5 arrow with the length of 5 units, and we stop at 8. How long is the arrow that represents 3? The arrow that represents 3 is 3 units long, and it's pointing to the right. So we'll write 3 units to the right. 3 units to the right. How long is the arrow that represents 5? What direction does it point? The arrow that represents 5 is 5 units and is pointing to the right. 5 units to the right. What is the sum? The sum of 3 and 5 is 8. If you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? So if I were to draw an arrow or a vector from 0 to 8, it will be 8 units long and it would point to the right. So 8 units to the right. 8 units to the right. What is the relationship between the arrow representing the number on the number line and the absolute value of the number? The arrow on the number line is the absolute value of that number, because if I were to draw an arrow that would be from 0 to 8, it will be 8 units long. And what is the absolute value of 8, or the distance from 0 to 8, is 8 units. So the length of the arrow is the absolute value. The length of the arrow is the absolute value. The length of the arrow is the absolute value of the number. Okay. Do you think that adding two positive integers would always give you a greater positive number? Why? Adding two positive integers, 3 plus 5, 2 plus 6, 10 plus 5, we are always going to go to the right of the 0 on the number line. And since we are always going to the right, we will end up with a greater positive number. So yes, because both arrows are going to the right. Because both arrows point to the right. On the number line. Okay. All right. Let's move on. And next one is represent the sum of -3 plus -5 using arrows on the number line. So now we are doing the same thing but adding negative numbers. We start at 0 going to -3, and then we start at -3 and going again to the left 5 units. This way we end up on -8. How long is the arrow that represents -3 and what direction does it point? -3 is going to be 3 units long. 3 units long, to the left. How long is the arrow that represents -5 and what direction does it point? 5 units to the left. 5 units to the left. 5 units to the left. What is the sum? -8. If you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? So again, if I were to draw a vector from 0 to -8, it will be 8 units to the left. 8 units to the left. Do you think that adding two negative integers will always give you a smaller negative number? Why? Yes, because both arrows are pointing to the left, and since I'm going more to the left, my number is getting smaller and smaller because bigger numbers are always to the right. So yes, because both arrows are pointing to the left. Yes, because both arrows point to the left. Okay, so here's the rule. When we add rational numbers with the same sign, we add the absolute values and use the common sign. So when we add the numbers with the same sign, we add the absolute values and use the sign. For example, -3 plus -5 will give you -8, just like we looked at our example. 3 plus 5 will give you 8. So when I add both positive signs, my sign is also positive in the answer. When I add negative signs, my sign is also negative in the answer, because both arrows are pointing in the same direction. These ones are always going to the left, these ones are always going to the right. 10 plus 7 is 17. We all know it from first grade, right? So 10 plus 7 is 17. However, -10 plus -7 will give you -17, because in this case we go to the left on the number line all the time, resulting in a smaller negative number. If I were to draw to give you another example, 21 plus 9 will give you 30. -21 plus -9 will give you -30. I hope that makes sense. Let's look at our examples here. Decide whether the sum will be positive or negative without actually calculating the sum. So here we are not calculating the sum. We are just looking at the signs. Here in -4 plus -2, I'm adding both signs that are negative. So both arrows on the number line are going to go to the negative direction, resulting in a negative sign. So negative. 5 plus 9, both numbers are positives, and the sum is also going to be positive. -6 plus -3 will give us -9. Oops, sorry, negative answer. Also adding two negative numbers, resulting in a negative answer. Adding all numbers that are positive, the positive answer is going to be our sum. Adding both numbers that are negative, so the answer is going to be also negative. Okay, so now we need to actually calculate the sum. 15 plus 7 is going to be 22, positive 22 because both numbers are positive. -4 plus -16 will give you -20. because you're adding two numbers with negative sign, your answer is going to be negative 20. Negative 18 plus negative 64. So that is going to be negative 82. A smaller negative sign when you're adding two negative numbers. Negative 205 plus negative 123 will give you negative 328. Again, we're adding two numbers with negative signs going to the left of the number line both times, resulting in a smaller negative number. Okay, so when I add two numbers with the same sign, I just add the numbers together and keep the sign. Example 2, the rule for adding opposite signs. So now the numbers will have different signs. One is positive, one is negative. Let's see how that works out. 5 plus negative 3. So on the number line, we are going to draw 5, and when we add negative 3, we will go to the left from the 5, resulting in 2. Okay, so how long is the arrow that represents 5? In what direction does it point? That'll be 5 units to the right. How long is the arrow that represents negative 3? And what direction does it point? This arrow is 3 units and pointing to the left. 3 units to the left. Which arrow is longer? The one that represents 5 or the one that represents negative 3? 5 is longer. The one representing 5 is longer. What is the sum? The sum is 2. If you were to represent the sum using the arrow, how long would the arrow be and what direction would it point? Since the sum is 2, it will be 2 units long, pointing to the right. 2 units to the right. Represent the sum of 4 and negative 7 using arrows on the number line. So I start at 0, go to the 4, and then stop at 4, start at 4, go 7 units to the left because 7 is a negative number, and I will stop at negative 3. How long is the arrow that represents 4? The arrow that represents 4 is 4 units long and it's pointing to the right. So 4 units to the right. How long is the arrow that represents negative 7? In what direction does it point? It will be 7 units and it goes to the left. Which arrow is longer? The arrow that represents negative 7 now is longer. The arrow that represents negative 7 is longer. What is the sum? The sum is negative 3. If you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? Okay, so my number negative 3 is 3 units away from the 0 to the left of the 0, so it will be 3 units to the left. Okay, in the two examples above, what is the relationship between the length of the arrow representing the sum and the lengths of the arrows representing the two atoms. Okay, so let's look at our first example here. What is the difference between this arrow and this arrow? So if I compare these two arrows, this will be the leftover or difference, right? And that is 2 units long pointing to the right. Okay. If I were to look at this, my second example, the difference, so this is the common part and this is the different part. And that is the difference and that is 3 units long and going to the left. Okay. So what is the relationship between the length of an arrow representing the sum and the lengths of the arrows representing the two atoms? The length of the arrow representing the sum is the difference between the two arrows. So the length of the sum is the difference between two arrows representing the atoms. And the atoms are the numbers that we add, right? So the length of the sum representing the length of the arrow representing the sum, if you look at me up here, is 3 units to the left, right? And that is actually the difference between these two. And that's what it is. The length of the arrow representing the sum is the difference between two arrows representing the atoms. What is the relationship between the direction of the arrow representing the sum and the direction of the arrows representing the two atoms? Again, let's look at our example here. The difference is going to be the larger arrow, right? The larger arrow is going to be the one that is different. So the direction is going to be of the arrow showing the higher absolute value, right? So longer arrow. Okay, so the arrow that is longer is going to give us the direction of the arrow representing the sum. Okay, so the longer arrow is going to represent the direction of the arrow of the sum. The longer arrow representing the addend will determines the direction of the arrow determines the direction of the arrow representing the sum. Okay, write the rule that will give the length and direction of the arrow representing the sum of the two values that have opposite signs. Okay, so if I were to add two numbers with the opposite sign, I will look at the difference of the two numbers, right? Difference of the two numbers, and we'll keep the direction of the longer arrow, right? Okay, so I'm going to add numbers with different signs find the difference of the two atoms. find the difference of the two addends. Find the difference of the two addends and keep the sign of the bigger arrow. And keep the sign of the, let's say, greater absolute value, more mathematically correct, of the greater absolute value. Does that make sense? If I'm adding two numbers with different signs, I will find their difference and keep, and difference means subtraction, right? And keep the sign of the bigger arrow. Okay. So instead of adding, I'm actually going to be subtracting to find their difference. Okay, so here's the rule. If that didn't make sense to you, here's the rule. Add rational numbers with opposite signs by subtracting the absolute values and using the sign of the integer with the greater absolute value. So to find the sum of two rational numbers, we are going to subtract the two numbers and keep the sign of the greater absolute value. Okay, so how does it apply to our numbers? Exercise 3. Circle the integer with the greater absolute value. Again, absolute value is the distance from 0 to that number on the number line. Decide whether the sum will be positive or negative without actually calculating the sum. Okay, so -1 plus 2. Which absolute value is the greater? 2 has a greater absolute value. So to find their sum, we are going to subtract the two numbers. 2 and 1, what is the difference? The difference is 1. Which is the higher absolute value? Positive. So my answer is actually going to be positive because that is going to be the longer arrow on the number line. So positive. Okay, 5 plus -9. Which arrow is going to be longer, 5 or 9? 9 is going to be longer, so -9 has the higher absolute value. So therefore, the answer is going to be negative. -6 plus 3. -6 plus 3. -6 will have a higher absolute value, therefore the answer is going to be negative. -11 plus 1. -11 will have the higher absolute value because the longer is the arrow, and the answer is going to be also negative. Okay, so now we need to find the sum. -10 plus 7. It's an addition problem, however, because the signs are different, we are going to subtract them. What is the difference between the arrow representing -10 and the arrow representing 7? 3 units. 3 units. The higher absolute value is -10, so the answer is going to be -3. Okay? 8 plus -16. -16 has a higher absolute value by how much? By 8. And since -16 is a negative number, so it will be -8. -12 plus 65. 65 has a higher absolute value. By how much? By 53. 53. And 105 plus -126. 126 has a higher absolute value, so the answer is going to be negative. By how much is it bigger? 126 minus 105 is going to be 21. -21 is our answer. Okay, so now how do I apply integer addition rules to rational numbers? Okay, so here we have we need to find the sum of 6 plus negative 2 and 1/4. Okay, so step 1, find the absolute value of each number. So the absolute value of 6 is going to be absolute value of 6. These are the brackets for showing absolute value is 6. The absolute value of negative 2 and 1/4 is positive 2 and 1/4. Subtract the absolute values. I'm going to subtract 6 and 2 and 1/4. So 6 minus 2 and 1/4. Remember how to subtract fractions or mixed numbers. If you can't subtract a fraction from anything, you need to borrow. 6, we are borrowing 1 and it becomes a 5. But that whole 1 that we borrow, we are splitting into 4 equal parts to be able to take 1/4 out. So it will be 4/4, right? Since we're splitting it into 4 units. 4/4 minus 1/4 is 3/4. And 5 minus 2 is 3. So the answer is 3 and 3/4. Okay? Since the answer will take the sign of the number that has the greater absolute value. Which one is greater, 6 or 2 and 1/4? 6 is greater. So the answer is positive 3 and 3/4. Okay. That is the end of our lesson 4. If you have any questions, please let me know. Otherwise, do your homework and I will talk to you in the next lesson.